Well, for this challenge, after first accessing the challenge address, it displays a JSON string containing the username and password. Then we start by performing a directory scan on the challenge. We use dir search here, and I've already started scanning a while ago. Currently, it has revealed three routes: www, an admin route, and a login route. We can try accessing them separately. The login route, it indicates that our request method is incorrect, suggesting we might need to try logging in via a post method. So this login route is likely a login interface. The second one is the www route. When we access www, it prompts us that it requires an HTTP request header. The name of this header is via. The third route is the admin route. The admin route tells us it requires a token. So up to this point in the challenge, we've obtained three pieces of information. First, a login interface. Second, a www route. Root, and third, an admin backend that requires a token for access. Now we first try, because the challenge initially gave us the username and password, so we first attempt to log in via this login interface to see if we can utilize it. So here we first try to access the login interface and attempt to log in. Since it said the request method was incorrect, we typically use a post request, so we change the request method here. Upon requesting again I'll find it requires data in JSON format. Here it says our data structure or type is invalid and it needs JSON data. That means through this error message we can guess the backend's data structure format is JSON. So first we change the concatenate here to JSON format and directly paste the username and password information we initially had. So essentially we are logging in using JSON format. After logging in, we find it gives us a token. Yes, it gives us a token. This token, well, obviously it's clearly a JWT token because it conforms to the JWT format. Next, let's look at the admin route again, because earlier our admin route indicated we needed to log in. Now when we access the admin route, it prompts that we need a token. So this token, how is it provided? First, for token authentication, we have several methods. It can be via a cookie or via a request header. After trying, we found that in this challenge, the token authentication method is through a request header. So we directly use this common standard, add the authorization header, and after bearer, follow it with the token. Then we can proceed. Involve our token in the verification process. So we first paste the token here, paste it, and request again. We find it prompts here saying it's insufficient privileges. So the current line of thinking for this challenge becomes clearer. We need to find the key. Since it's a JWT token, we need to find its encryption key and then change its permissions. We can decode it. Take a look. Very clearly, after decoding this JWT, the role here is guest. Its permission is also guest. So we need to find the secret key and then change its permission to get the backend flag. At this point, the only unused route is the www route. So what role does it play? We can conduct a test. Now let's go back to the www route since I've already cleared some unnecessary things here, and because it prompted us for a via header, we try giving it something. We can discover that no matter what we give it, the response content is consistent, exactly the same. At this point, we need to switch our way of thinking because in a request, not only the response content can give you information, the response time can also vary. So if we observe the response content is consistent, then we need to see if there are any hints through other means. So now we first try to capture its response time. We can brute force it. This will, well, let's assume it's the first character. Assume one character. Here we write a simple Python script. So let's first see if under different codes or different first characters, its response content or its response time will be different. So first we put the challenge URL here, prepare a character set, and then perform a test on it here. Since the secret is empty by default and adding I here represents, well, it's one character, well, perform a brute force and then let's run it. Let's see if there will be an anomaly. Now, well, just enter one character. We find its normal response time is around 27 milliseconds. See, we randomly enter a character. 29, it's all around 30. So now we use the response time to see if there's a character whose time is greater than 30 milliseconds. That's what the commented code below does. Is there one that can be greater than 0.03? If there is one greater than 0.03, we print it out. Let's run it. Let's see, print. Wait a moment. Or let's switch to a different method. Print out all characters and their corresponding times. Yes, let's do it this way. Good, then we can observe these. Good, then let's look at it. Let's test its delay. Still using the previous example, we run it and find that when it's greater than 0.03 seconds, the output is 2. That means we've found a character when via equals 2. The delay here significantly increases. If I change it to a there's no increase, it becomes 27 again. If changed to 2, it increases to about 70 milliseconds. So if our first character hits, the secret key character is in the first position, its delay will change noticeably. What about the second position, right? What is the pattern for the second, third, fourth characters? So we need to find its second character. What is the time like for the second character of the secret key? We guess it must be greater than 70 milliseconds, otherwise the pattern wouldn't hold. So here we manually change the first character of the secret to 2 and then change this threshold to 0.07, make it greater than 0.07. Let's look at its output again. We can see when the second character equals I, our delay increases significantly, again becoming 118. So the first character is 2, it's 68. The second character is I, it becomes around 119, 118. We can calculate the difference between these two. This 119 minus actually the approximate value is around 49. I can conduct several trials, 69, 76, 66. And here for I, it's around 120, 121, 119. Around 120 minus, say, 65, 66. Such a difference. Anyway, it roughly stays within a range. So Using this range, we can brute force the secret key. This is a side channel leakage. Here is just a simple demonstration of the principle for the actual exploit script well. Essentially, we used the idea just discussed to perform a brute force. First, there is a list of characters for the secret. A character list. The second is the length of the secret key. Usually our secret key is 16 characters, but you can also increase it. We judge whether we have successfully brute forced completely by observing if the delay no longer increases. Good. Then we set a threshold time. Here we can set it to 0.03535 ms or 0.05555 ms or 0.0440 ms. This depends on our network conditions based on the test results from the first two characters to determine what the time difference is. Then we can proceed with the brute force. So after brute forcing, we obtain the key. This brute force takes some time. I've already run the exploit script in advance, so we can see our complete key is like this, just like this. You see each additional character increases the delay by about 50 milliseconds, 35 to 50 milliseconds. Around 35 to 50 milliseconds. So eventually, we brute force out such a key. After obtaining this key, we can directly sign that token JWT. Of course, you can sign it via code or through a service. Here we can resign it. We paste the token back, select the JWT sign module for the secret key. Here we choose the key. We just brute forced this key. Then we change all permissions to admin. All changed to admin. So here I get this new key. After obtaining this key, we directly paste it here, place it under the admin route, and send the request. Then we get a flag field. Of course, this is an initial flag. So we've obtained our flag.